Okay. If there's a part 2 to the note, somebody needs to tell me. Thanks. Now, knucklehead, I didn't know it. So some of those problems could have been difficult. Also, if you're going to do delta math, you have to go through Clever. You have to go through Clever to get there. The 2 people that emailed me this weekend found that out, I guess. The ones that didn't email me didn't know it. Okay. So, my bad. No wonder some of those questions are probably hard for you. You had to find the R. That was part 2 of the notes. I don't have it even up here. Let's do this. This was your worksheet. Which one? What difficulty? Where? What do I need to do? Which one? The back page? Like these? Like those 2? That cover the notes that you probably didn't know how to do? Yeah, imagine that. Wonder how that works. My bad. Sorry. I have no idea how to do this. We went over in class. No, we did not. Oh, oops. You don't have to talk to me. Okay. What is that? G sub 2 equals 1? It's your worksheet. Is that what it is? Okay. And then equals? Okay. So in this particular, in the geometrics, guys, y'all had to, in the arithmetics, you had to find D. And D's pretty easy on those because you basically take the difference here and take the difference here and just divide them, and that finds the D, the common difference between them. This one's harder to find the common ratio because it's just a little harder. So between 27 and 1, and then you got 5 and 2. So there's 3 different numbers to get from 1 to 27. Right? So the second term is 1. The third term is something, the fourth term is something, and the fifth term is 27. Okay with that, right? So let's see. What's the best way for me to do this for you? Probably should go over those notes real quick. I don't even know where they are. They're not there. Let's go here. 2.1. Let's go worksheets, notes. 2.1. Man, sorry about that. 2.1 notes. Well, that's why my notes stopped. Well, cuss. Part 2. Huh? Continued. First mistake this year. That was a bad one. Okay, let's finish these notes. I got to do something else. Sorry. Bear with me. Right click, download. Download it. Part 2, desktop, good enough. Save. Minimize. Minimize. Hit that. Hit this. Worksheet. Oh, that's worksheet. Get over there. No. What? Go away. Just playing Tetris over here. By gosh, I'm got there. Oops. Take 2. Good morning. How was your weekend? Hope everybody's good. I messed up the other day and didn't finish the notes, so we're going to finish those notes first. See how it works? Just act like this is the first time. I should have hit pause on my recording. A geometric sequence has successive terms that are common ratio, yada, yada, yada. This means that each term multiplied by the same number generated. General form of the geometric is that. You already know that. You should know those 2 things. Find an equation for the geometric with G3 is -3 and R is 10. So I know that G3 is -3, and we know that G sub n is equal to G sub k R n minus 1. Okay? You just got to memorize that. Like I said, there's no other way to do that but to memorize it. And I know that G of 3 is -3. So this is going to be G of 3. R is 10. N is that common thing that's always there, 1. And so that's just going to be -3 10 n minus 1 equals G of n. By the way, if they ever ask for an equation, I think this was said, I'm pretty sure. If they ask for an equation on anything, homework, test, and you don't put f of x or r of x or s of t or whatever equals, it's wrong. Every time. Every time. That last question was pretty easy to grade for a lot of you guys because I didn't see an equal sign anywhere. Yep.
I have a question. So it says in the equation, it's like r raised to the power of n minus k. So why would this?
Oh, that makes sense because I'm an idiot. I knew that was too easy. N minus k. Thank you. Thank you. N minus 3. Because k was 3, right? There. So if I plug in, oh, no, we don't have to find anything else now. Don't multiply the -3 and a 10, right? Don't. Is that better? Is that better? Okay. Now, this is what we need in order to do those other questions. So, G sub n, geometric G sub 2 is 24. Oh, no, sorry, R is 1/2. This one's not that bad. We know this one. So we know G of n is equal to G of k R n minus k. Now that I know the formula right. So G of 2 is 24. R is 1/2 n minus 2. Okay, easy when they give you what R is. They're easy. But the arithmetics are pretty easy when they give you D. When they don't give you D, it's still not too bad because it's easy to figure out that difference by doing a ratio. Okay. Now, These examples above are relatively quick and easy. That's what I just said, because we're given one term of the sequence and the value of r. However, we can deal with problems that give us two terms, but not the value of r. So here's what you do when you do this, which is what Miss Berry just said that she did. She had to learn it by herself because I didn't teach it, because I'm an idiot. Use both terms to create one equation in general form. Use the larger k values as g of n term. Solve for r using the equations that were created from step 1. This will make sense to you in a second. Use the value of r found in step 2 along with either term in the problem to write the general form. So here's what they want us to do for this particular problem. Oh, and you can do this with arithmetic. It's just easier just to, I don't know, mentally think about the arithmetic. So use both terms to create one equation. So let's see, we got g of 3 is -2, and we got g of 6 is 128. And we know that g of n is equal to g of k r n minus k. So what I'm going to do is make this equation right here. So g of 3 is -2. R to the n plus 2. Use both terms, create one equation in general form. I'm drawing a blank on how I remember how to do this. Then I got g of n equals, save yourself some lead first because you might have to erase some of this crap. 128 r n minus 6. Create one equation. Got to check. 3 plus 2 is 5. 2, that's not right. 6 plus 2, 6 minus 6. N plus 2, -2. How'd I tell you how to do it?
Well, one, it's n plus, or n minus 3 on the first one, because -2 is g of 3, so k is 3.
Slow down.
On the blue equation, k
Oh, k is 3. Oh, it's n minus 3. Okay.
And you told me to do it by...
Uh-oh. Oh, it's blue. Where's my blue? -3. Told you. What'd I tell you?
Do it by dividing the second term by the first term, and then
Taking the root.
taking the root of the cube.
Okay. 128 divided by 3. Yeah, that's divided by 2. 64. And that's what, 3? So I'll take the cube root to the 1/3. Bear with me. Yeah, 4. Okay. I don't do it the way he does it. He, pass water. Told you. Save yourself some pencils. Okay, so here's how I do this. Right, wrong, and different. Geometric or exponentials. Arithmetic or linear. So that's why you can just do the difference and the difference and figure out that ratio to figure out what D is. In this particular one, I'm going to take 128 and divide it by -2. So 128 divided by -2. 60, what, 4? Negative. Okay? So it's 64 negative. So there's a multiplicity, if you will, of between negative 2 and 1/28 of 64. And there's what? 3 to 6 is 3 terms. Okay with that? And so I'm going to take the cube root of that because it's 3 terms. So I'm going to take the cube root of negative 64. That'll be your R value. It's easier than trying to do it with the equations. You're kind of doing it the same way with the D. You're not using the equations. You're just figuring it out. You're just kind of figuring it out here. And then once you have R, you can use either this one or this one to write the equation, bless. Either one, because it'll be the same equation. I always use the smaller one. And so we'll say G of n equals G of 3, which is negative 2. Now R is negative 4. And then I got what? N plus or n minus 3. That's a 3. Let me check to make sure. I'm gonna plug in 6. Okay, so 6 minus 3 is 3. So I got negative 4. Too fast. Clear. Negative 4 to the third times negative 2, which is 128. I was checking this one to make sure it worked. Y'all see what y'all follow what I did there? So divide the 2, and because there's 3 terms between it, take the cube root. If there's 4 terms between it, take the 4th root. Y'all know how to do roots on your calculator? Surely, I would hope. Let me make sure. Where's my calculator? Here it is. So as that's coming up, let's pull up this one. Okay, here we go. So 1.5 and 48. 1.5 and 48. Yuck. .0 whatever. Turn it to a fraction. You know how to do that? Math. Enter. Enter. I'll show everybody just to make sure. Okay, here's my calculator, right? What was it? 1.5 divided by 48. Okay, so that's the ugly number. I want that as a fraction because it's nasty looking. So we'll do math, and the very first one, that's an arrow fraction, so that turns things to fractions. If you want to turn it to a decimal, it turns it to a decimal. There's cube root. I'm sorry, that's cubed. That's cube root. That's the 4th root or 5th root or 6th root or whatever you want. I don't ever use that. I just raise it to the power. I'll show you in a second. So it's 1 over 32. Okay, and it's going to be a nice number. Was that that somebody just got home? Wasn't mine. So, and then I got to figure out how many terms were there between this one? 5 terms. So I got to find the 5th root of this one. Okay, and so all I do to do the 5th root is I raise it to the 1/5 power. That's easier than trying to find a 5th root for me. If you raise it to the 1/5 power, that's the same thing as a 5th root, which is 1 over 2. And so R is 1 over 2. They do them with nice numbers. They're not going to make them nasty numbers. They're not going to make them nasty numbers. They could. They don't. Where'd we go? This thing. So when I take the 5th root of that, that's 1/2, and that's R. And then I just always go back to so G of n is equal to 48. R is 1/2. You could put 0.5 if you want to. And then n minus 2. And if you want to verify, plug in 7 and you better get 1.5. Plug in 7 and you better get 1.5. Do we? Surely. Okay, y'all good with that? I think it's easier to do it that way than his way. So now we'll go back to this worksheet. (27) divided by 1 is 27. And there's 3 between it, so we're just going to take the cube root of it. R is 3. And so if R is 3, we'll go to G of n equals, we'll do 1, 3 to the n minus 1. And when I get 5, I'll do 5 minus 1, which is 4, and 3 to the, I do that all the time. It's n minus 2. Stupid 2 right here. I just checked it and I knew I was wrong. I need to go back to bed. No, I don't want that. I want this. So I checked it. I plugged in 5. I said 5 minus 1 is 4. 3 to the 4th is 81. I knew I was wrong. And it's because it was a stupid 2. So now I got to make that a 2. There. Now, 5 minus 4 is 3. 3 cubed is 27. That works. So what's this last one? You do 32/9 over negative 12. I don't know. Eight 27ths. Negative, take the cube root of it, 2/3. That's R. Everybody okay with your calculator on that? Okay. My bad. What other questions do you have over the homework now that, I mean, hopefully you knew how to do the other stuff, but surely I would have expected some dang questions over email this weekend. Surely. Don't call me Shirley. The heck? Was this, are these a geometric, arithmetic, or nothing? Is that what they asked on these? On number 18? Oh, man, my angle, that was looking like they were the same number. I thought it was 6 and negative 3 at 1. But let's see, that's 1, 2, 3. Okay. Okay, I feel better now. Yay. All right, beautiful. What else? Everybody okay? We know geometry. You gotta know this to do today's. I mean, you got to know this to pass the test, but you got to know this to do today's for sure. Everybody okay? Good? Yay, yay, yay. All right, so go through Clever to get the delta. I didn't want to do it that way, but it has to be that way because we had to pay for delta. So you have to go through Clever. (2.2). I did get done with y'all's tests this weekend. Some of you did really, really, really good. Some of you did not. There were some got like 0 points on the free response. 0. Okay. In the last section, we learned arithmetic sequences behave like linear functions. Line R. And geometric sequences behave like that's not how you spell it, I know. Exponential functions. Okay, you got to kind of have to know that. We also learned these formulas. This is arithmetic, a sub 0, d sub n. We don't use that one. I tend to use this one because I don't want to have to remember two of them. And this one works for this one. This is the same as the point slope, or sorry, the slope intercept form. Because you have a sub 0, which is like your initial term. When it's 0, that's your y-intercept. And then d is your slope. Okay, so that one and this one kind of go hand in hand. This one and this one go hand in hand, which we kind of have to start getting away from this one because very few times do you want to write an equation in slope-intercept form because it's just rearranging and just leave it like this and it's a whole lot easier. And that's what we did. We left them like this. This is the point slope form. M equals y minus y over x minus x. And this is the y minus the y part, and here's the x minus the x part, and there's the m. So that's y sub I, which is whichever point we're talking about. First point, second point, third point, fifth point. M is that slope, it's that common difference. That x is the n, and that x sub, or that x sub I is the same as that y sub I. So just kind of tie those in together. Same way with the exponential. G sub 0 r to the n is the same thing as a b to the x, or a r to the x. That's the same thing. This is if you have a point that don't have the initial point, the 0 point. Y sub I is the same thing as the g sub k. R is a ratio, and then the x minus whatever term that is, x minus whatever term that is. So this really hasn't told you anything other than make sure you can link the arithmetic to linear and the geometric to exponential. Over equal length input values, they change at a constant rate. We learned this in chapter or unit 1, right? If the difference is constant, it's linear. If the difference was double, it was quadratic, or if it took 2 to get to be a constant. Now we're going to look at the difference being proportionals as opposed to be linear. All right, so the change in base is based on addition. The change in base, that's it right there on my desk. I'm babe. Yep. Shoot, yeah. The change is based on addition. The change is based on multiplication. This will make a whole lot of sense when we get into the example. If you have 2 points, you can write the equation of a line, exponential function, arithmetic, or a geometric sequence. Okay? All right, so here we go. Example and number uno. Selected values of the input functions are given in the table below. So we got an A and a B and a C and a D. Okay? For each table, determine if the function could be linear, exponential, or neither, and give a reason. Always check to make sure those are constant. Always check to make sure those are constant. -2, -2, -2, -2. Good enough? L-I-N-E-A-R. Does that show enough work? Yep, it does. I did. The reason, it's constant. Does that make you feel better if I say constant? So whenever it says, guys, give a reason, you can give a reason mathematically, you can give it verbally, or you can give it, I don't know what else there is, graphically. Graphically, verbally, mathematically. I gave you the reason mathematically. Fair enough? Then I gave it to you verbally. I'm not going to give it to you graphically, but you can graph it. Fair enough? Graph those points, and because they're in a straight line, we're good. Yay? So do that however you want. Red. 1, 1, 1, 1. That's good. That's 1. That's 3. That's 5. And that's 7. Huh? I can't multiply this by something and multiply it by something and multiply it by something and multiply it by something. If I have a difference now, this is a 2 and this is a 2 and this is a 2, that's not exponential. It's not linear. It's actually quadratic. What they just asked, is it linear, exponential, or neither? So you say neither, but you could say because it's quadratic or whatever you want to do, right? Neither. The second difference is constant. Makes quadratic. Beautiful. Neither. Huh. Good enough. All right. Brown. 2, 2, 2, 2. I have never not seen those not constant. Just be sure. Okay, so that's 1, that's 2, that's 4, and that's 8. Right? 1, 2, 4, 8. Which means it's multiplication. R being 2. Because you multiply it by 2, multiply it by 2, multiply it by 2. Exponential. Common, I won't say common difference, common ratio. How about this? Common ratio. Whoops. 2. Good enough? 5, 5, 5, 5. What's 40? That's 20. That's 10. And that's 5. Oh, and they're down, it's going down, right? Well, yeah, but it's multiplication. Right? It's going down. She said it shouldn't be negative. You're going down, but it's still multiplication. So you're not multiplying by a negative. Good. Because you're, and I say you're multiplying, really you're dividing. But if you're dividing, you are multiplying. You're multiplying by 1/2. So exponential. Good? Yes? Not hard? Beautiful. Word problems. Beautiful. Mr. Passwater. A wild rumor is spreading. Mr. Passwater won 3rd place at the world's strongest men contest. Mr. Passwater definitely, probably didn't start this rumor. If you saw Mr. Passwater, you would definitely know it was a rumor. I'm just saying, it's a rumor. Unless if, no, it's a rumor. The number of people have heard the rumor can be modeled using a geometric sequence. So we know we are exponentiated. 43 people heard the rumor on day 3. 140 heard it on day 6. According to the model, how many people to the nearest whole number heard it by day 10? Well, first I got to figure out what R is. And so R, we're going to take it and divide this, and then we're going to take the cube root of it. And these are not going to be pretty because these are word problems. Okay? So they're not going to be pretty. So we're going to take our little calculator, and we're going to take that 140, and we're going to divide that by the 43. Get something pretty nasty. You can try to change that to a fraction, but you probably won't, except it's going to turn it to 140 over 43 because it doesn't change into a fraction. And then we're going to take the cube root of that, 1/3. And so that's the R value, which is not the best thing in the world. Leave that in your calculator, though. Don't round. Round on your paper, but don't round. Don't ever round. Don't. If you have to, start doing this. Hit this little STO button. That's going to store it wherever you put it, like alpha R for ratio, but you can put alpha A or alpha B or whatever you want. I don't know where R is. OPQR, R. Now, every time I use R, it uses that number, and it uses the whole thing. Even though it stops at the 1, it doesn't stop at the 1. It just keeps on going. It has it memorized. So kind of get into that habit. Don't round anything in this class, ever. You can round it on your paper. Don't round it in your calculator. Okay, so now let's go back. I'm sorry. That was soapbox. So we have G sub n equals, and I can use either one of these. I'll just use the top one. I'll say 43 R, or what was it, 1 point something? Let's go ahead and put that there. That way we know. 1 point something. What was it? Y'all got it? Was it? 482. How many decimal places we got around in this class? Okay, I thought it was 3. Some of us didn't. 8 what for? 2. N minus 3. Everybody good? Now we're just plugging and chugging. So I'm going to go back to my little calculator here, and I'm going to do 43 times, whoops, that's division, times R to the, how many do they want? 10 minus 3, 7. A bunch of people. Round it to the what nearest integer? 676. That's not right. Surely more heard it by then. How many heard it on day what? 3? Oh, yeah, that's probably right. 676. Beautiful. About 676 people. To the nearest whole number have heard the rumor by day 10. About 676. If that was a test, you might say heard the rumor by day 10. Beautiful. Yes.
On the test, do you care if we write the equation or not?
If it tells you to, yes. If you don't, on this one, you didn't have to. Fair enough? You don't want a naked answer. Like you don't want just this. Right? Because you want to have something there. Now, your last test had a bunch of naked answers because there was no work to be shown. You could have done a little bit, but there wasn't. I mean, the only thing you would have done is maybe circle something and then write it, whatever. There wasn't a whole lot of work to be shown last test. A large theater has rows of seats where the row of seats in each row can be modeled by an arithmetic sequence. The 5th row has 31. Let's change. Let's go gray. The fifth row has 31. Yeah. And the 11th row has 49. Determine how many seats there are on the 25th. So what we got, 18 and 6. D is 3. Difference here, divide it. So now A sub n equals either one of these two. 31 plus 3 n minus, I already wrote something extra, 5? Yeah. And then we're just going to plug 25 in there. $25, 20 times 3 is 60, 81. What's the number? 91? See? Thank you. Gotta get my stick. You don't know about this stick yet. Is there any more to these notes?
No.
No? That's all there is. You mean I just spent a whopping whatever? Man. That's all there is to these notes? Surely we're supposed to do 2 lessons today. Apparently we're not, because I graded y'all's tests. I'll put them in just as soon as you leave. I want y'all to have a good day. When you guess, you have to guess the correct one.